Good morning, everyone. Are you awake yet? Yes. Now you are. Very good. Hey, I have good news. Whatever you're doing today, it's over. And you think I'm kidding, but I'm not. It's actually, there is something quite fundamental happening to software engineering as we speak. And I think all of you are aware of it. I think many of you are trying to push it away a little bit and not think too hard about it. But what I believe is that the role of software engineering and the role of software engineers is fundamentally changing. And that's why this is a very dark, not so positive title, right? So I added a little subtitle to it, As We Know It. Doesn't that feel good? Okay, good. Let's get into this. I asked ChatGPT, what does the end of software engineering look like? And you know what I got? I got this. Is that cool? I thought it was pretty neat. Because that software engineer doesn't look particularly happy, and he's being sucked up into some kind of cloud and become part of some kind of general AI intelligence, which I thought was pretty cool. But here is what we see happen. On the one hand, Gen AI, generative AI, is starting to support or fully automate many of the things that we used to do by hand. Yeah, so we have anything from code generation, test case generation, architecture design, requirement specification, validation. All these things are increasingly either actively supported or fully automated with artificial intelligence. On the other hand, we have some pesky people in Brussels that are trying to make our lives incredibly complicated with all the regulations, acts, and laws that are basically being forced down our throats. So we have things like GDPR, we have the Data Act, we have the AI Act, we have the Product Liability Act, the Cyber Resilience Act, and all these things we actually need to work on in order to be able to sell our products. One of the companies that we work with, a Swedish truck company, we have two, I will not tell you which one it is, they claim that they have to follow somewhere between 250 and 300 different acts, laws, and regulations in order to be able to sell their products worldwide. Yeah, so we see this tension in between those two things. But what I believe is now really happening is this is how we used to build software. We have an intent. We want to accomplish something. We translate that intent into some requirements. We do a design. We create a code. And of course, we compile and test and all this other good stuff. And then we get a system in operation. That's how we've worked for many, many, many years. This is where the world is going. You will tell a system what you want from it, and then it generates it. It will generate, how will I quantitatively measure that this system is actually doing what I want it to do? What are the requirements that I need to generate? What is the code that I need to generate? And what is the detailed design that I need to generate? And then I get a system in operation. And this system in operation will not be static. It will not just be sitting there. No, those agents, that AI intelligence will stay part of the system, will constantly evaluate what is happening, and then try to experiment with the behavior of the system in order to make it better. And we have solutions for that. I mean, reinforcement learning, I'm not sure who here plays with reinforcement learning. Yeah, but it's basically a technique. You waved. You work with reinforcement learning, right? No, okay. But you remember the Atari games? There was DeepMind, I think it was DeepMind in London, that had basically built an agent that learned every Atari game, for some of you that are in my age group, yeah, and learned to play it better than any human ever played Atari games in the past. And the idea behind reinforcement learning basically is that you give the algorithm a reward function, you give it an action space, you give it a state space, and basically it starts to randomly experiment with different actions in order to figure out what works. And then based on the things that work best, the system learns over time what is the right way of behaving. And then it becomes actually better all the time. We also have vertical AI agents that basically can regenerate code at runtime in order to make the system do better. Yeah, so that's where we're going. Of course, we're not there yet. So what we now see, and I think that this is the job that software engineers now have to work with, is that some of these things will be on the human side, and some of those things will be on the system side. And what we're trying to do is to push more and more of the things that we used to do towards the systems, because we are too expensive, and we need to find ways in order to generate systems, software-intensive systems, at a more cost-effective fashion than what we've done in the past. And once we have completed this journey, you know what the future will look like? It looks like this. Because I asked ChatGPT also to generate what the fabulous future of AI-driven software engineering will look like. And I showed this to a colleague, and she said, "Oh, I'm really disappointed because we're still going to offices, sitting behind desks and looking at screens. I think that's pretty boring." But you know, you have even a flying robot up there, which I think is pretty cool. Are you still with me? Are you against me? You're all looking at this picture, right? There's a bit of detail in there. I was actually quite impressed. So the key takeaways. The first thing which I really want to get across, we think that we're pretty good at building software. And that AI will have a really hard time to replace us, the brilliant software engineers. And what I will try to convince you of is that the effectiveness of software development, of product development today, effectiveness measured in terms of how much value, how much revenue are you generating for every hour of engineering effort that you insert into products, is really, really poor. We really are not very good at building software these days. Not you, other software engineers. Yeah, just. Gen AI provides a significant opportunity for improvement. This is not something that you can just, put by the wayside. This is an opportunity for you to become 10 times more productive than what you would otherwise have been. This is really an opportunity. This is not a threat. Software engineers are not going away. What is happening is that we're going to be 10 times as productive. And have anyone here heard of Jevons paradox? Yeah, Jevons paradox, there's one person here who knows it. It basically says that every time there is a new technology that significantly lowers the cost of something, the demand for that product goes up with at least that amount, if not more. So what we're going to see is we're going to see an explosion of the amount of software that is going to be demanded, because software is going to be so much cheaper that there will be so much more demand that everything that we now have will actually require all of us, but we are going to be generating 10 to 100 times more software than what we've done in the past. That's my prediction. Now, I know Yogi Berra, the American baseball player, you know him? You've heard him? Yeah, he used to say prediction is hard, especially about the future. Yeah, but this is my prediction at least. However, in order to grasp these benefits, we have to make some systemic changes in the way that we work with software and the way that we build things. Those are the 3 things that I wanted to get across. Does this sound like a relevant conversation? What I forgot to mention in the beginning, you can stop me anywhere during the talk. Yeah, you don't have to wait until the end. The organizers were a little bit like, 126 people in the room, is this a good idea? I think it's a good idea. So when you disagree with me, whenever you have a question or you disagree with me, you want to challenge me, raise your hand and we'll go and have a discussion. Is that okay? I may have to repeat the question because we're recording this, but that's basically the question. Yes, ma'am.
Doesn't already your DevOps report state that only like 19% of all developers responding to their survey actually do development the way that we now know is the best one? I think it's old news that we're crap at what we're doing.
Good. I will. So the question is, Jan, you are not opening any new doors because I already knew that as software engineers we're really poor at what we're doing. Yes. No. Other software engineers, not the ones in the room, just to be clear, right? Okay, don't say what you were going to say. Let's put it like that. That's a really good point. So what I was hoping to cover with you is give you a quick introduction in who I am and what my background is. Then I want to talk a minute about Software Center. Then I want to talk about the state of software engineering, AI maturity models, the software development lifecycle 2.0, and then its conclusions. That's what I was hoping to do. I have many other presentations on that computer. If you don't like it, tell me to stop. I'll switch presentation. Yeah. Very briefly about me, I used to be a young and innocent professor of software engineering. Early 2000, I got a call from Nokia. You remember Nokia? Yeah? I ran the Software and Application Technologies Lab, and I got an opportunity to move to Intuit, the company that you see there at the bottom, in 2007. But then in 2008, 2009, do people remember what happened with Nokia? The year I left, we shipped more than 400 million mobile phones. Nokia was the absolute top dog in the industry. Yeah, in the same we had, for instance, a company like Ericsson is now the top dog in the telecommunications industry. Yeah. Over a period of 9 months, Nokia gets completely disrupted. And the market gets divided between 2 companies in terms of making money. And I think you all know what they are. Apple and Samsung. And Nokia is basically disappearing. Nokia goes from being the top dog in the industry to the poodle in the corner that everyone likes to kick in a period of 9 months. Now, I personally hate poodles. I actually think poodles deserve to be kicked. Aww. But you don't want to be the poodle of your industry. So the reason that I'm having this conversation with you here today is because I really want to reinforce the importance of you proactively adopting these new technologies that are now becoming available. Because any company that doesn't adopt these technologies is going to be disrupted. We are at a stage where there is fundamental disruption taking place in industry. And if you work for SAP, I think you're pretty safe because the defense industry is very conservative. But if you work with any of the other companies, I think there's a huge risk of being disrupted. Yeah, then in 2011 I came back to Sweden. Jag pratar svenska om ni vill ställa frågor på svenska så går det helt utmärkt. I just can't present in Swedish. So. Yeah, I also run a small consultancy, and I do angel investing. So if you want to start your own company and you're looking for an angel investor, someone cool like me, you come and talk to me, yeah? But that's not what I really wanted to talk about. I run something called Software Center. I'm director of Software Center. It's a collaboration between 15 companies, 5 universities, and the focus of this is accelerating digitalization. We define digitalization as software, data, and artificial intelligence. And with all these companies, we are working with, first we help them with their software engineering practices, then we help them with their data-driven practices, and now it's mostly focused on working with their AI-driven practices. Yeah, so and it's companies that you probably recognize, like SAP here in town, Ericsson here in town, but also companies like Jeppesen, which was part of Boeing until last week. The 2 Volvos, Adveniga is a mid-sized company, or SME in Malmö doing military-grade encryption. German companies like Bosch and Siemens. No, that Bosch is not related to me in any way. I wish it was. You really think I would be standing here giving talks in front of a conference? Yeah, and those are the kind of companies that I think you all know and are aware of. So what we do is we work with these companies to help them change faster than what they would do without our help. We work in sprints of 6 months, which I know are ridiculously long from a software development perspective, but they're also ridiculously short from a research perspective. And like Responsive and this conference, we do not only focus on hardcore technology stuff, we focus on business aspects, architecture, ways of working, organizational aspects. We do all kinds of cool things with all kinds of cool companies that we talk to from time to time. I mean, King is one of those money printing machines that I just love. But in any case, that's where we are. State of software engineering. The first thing to realize is, how do we deliver value to customers? And what I'm seeing is a continuous shortening of the time that we have between value delivery to customers. We started with product generations. If you go to AB Volvo or Scania, they work with truck platforms, and those truck platforms are updated every 7 years. Which means that even though there are short, small updates every so often, the big value increases happen every 7 years. Yeah, and that's a very long value delivery cycle. Then we move towards what we call annual software updates. You all remember this? This already has started to happen in the 90s and in the early 2000s, when the SAPs of this world and the Oracles of this world started to do yearly software updates. And what happens is that once a year there was a new release, you installed it, nothing worked. You had 2 weeks of hell when you were trying to get everything going again because there were all kinds of backward compatibility changes. And then you could basically go back to sleep for another 48 weeks out of the year because everything was working, you didn't have to do anything. Now it's data ops, DevOps, and ML or AI ops. So every 2 to 4 weeks, we push out new value to customers. So the cycle is shortening, you can see that. But it won't stop there. We're also working on A/B testing. We've done A/B testing in cars. We've done A/B testing in telecom networks and in other places. And the idea behind A/B testing is that you basically have version A of a feature and version B of a feature deployed at different customers. You measure which of those versions is actually performing better. And then you decide, well, we're going to give everyone version A of a feature or version B of a feature because it turns out that that's the better version. And then the final technology. And then within a few days, you can actually get new value out. And of course, the last one is reinforcement learning, where you have within minutes or hours, the system is starting to optimize itself for the context in which it is actually placed. So what we see is a very immediate and continuous shortening of value delivery cycles in the industry, and we have to basically deal with that. With a colleague of mine who happens to be in the room here, I developed a model on how do companies actually go from a traditional way of working to a much more digital way of working. And what you look at is, let's start with the business model, and then you can read the other things for yourself. We start with traditional product sales, then we do product as a service sales. Product as a service sales is, for instance, if you go to Volvo Cars, you get a car as a subscription. You can get the XC40 as a subscription. You pay a couple of thousand kroner every month. When you're done with the car, you cancel the subscription, car goes away, problem solved, which my car is currently being serviced. I know it's going to be a humongous bill. Not a happy place to be, so I would very much like to have a car as a subscription service so that Volvo can take care of those issues. I drive an Audi, by the way. Don't buy an Audi. Complementary services around the product, that's what Volvo Trucks is currently doing, right? Basically what they have set as a strategy is 50% of our revenue for AB Volvo will be service revenue. So half of it will be selling trucks, the other half will be selling services. And these are uptime services, trailer services, tire services, fueling services, safe resting place services, etc., etc. So what you get is more and more complementary services around products. The fourth stage is when you go to the business customer KPI business model. Then you get paid every time the customer does something with your product that is valuable to that customer. Yeah, so if you are selling trucks, you don't get paid for the truck anymore. What you get paid for is every time a customer does an on-time delivery with that truck. Yeah, for SAP, that means every time you successfully shoot down a Russian... Oh, sorry, that was not the right example. Sorry about that. Yeah, but I mean, the idea basically is... Was that funny? I don't know. I don't know if that is humor in this room or not. Yeah, but the idea is basically you now align your monetization, your business model, with how customers are making their money. And the final one is the multi-sided ecosystem. But what happens is that you collect data from your primary customer base, and then you process and repackage that data, and you sell that data to another customer base. Yeah, and what happens is that because you can sell the data to that customer base, you can subsidize your products here, which you can then use to generate more data because your market share goes up, which allows you, because you have more data, you can make more money, and then you can subsidize your primary product. And in that way, you see that in digital markets, there tends to be a winner-takes-all strategy. You must have noticed that. Yeah, and what this means has huge implications on how we actually build our products. For instance, the way we work with data. If you're in the early stages, you collect data for quality assurance and diagnostics. If you are in the service, the product as a service sales, you collect data for product performance. How well is my product performing in the field? If you go to complementary services, very often these customers want to collect data that gives them insight in how well they are performing. So if you're a fleet owner and you have 100 trucks, you want to know how well are you performing, how well are each of your trucks performing. When you go to the fourth stage, it's about how does data actually of the entire customer base used to serve individual customer base. So if you go to Ericsson, for instance, they have a service where operators can ask, how well am I performing on some set of KPIs compared to other operators? If you're a fleet owner, you can ask to compare yourself to other fleet owners. When I worked for Intuit, the company that I mentioned earlier, we had a small business accounting solution which allowed all kinds of shops. We had more than 7 million small businesses using QuickBooks. And what we could do is basically ask questions. As a customer, you could ask questions. I have a flower shop. How much inventory do other flower shops hold? What is the average salary that other flower shops pay their employees? And those kind of questions allow you then to compare yourself. And then in the final stage, you're actually instrumenting your primary product with data collection capabilities that the customer using that product has no need for whatsoever, but you need the data because you're selling the data to someone else. You with me still? Or are you against me? You know, people, yes, sir, go ahead. Yes, there are lots of practical problems, yes. We're being recorded, so I will refrain from responding on that. But I've been in several workshops where we are basically asking, okay, what is the value of a truck? Go ahead. Sorry, you were making a point.
Yeah, so, for example, take OKR systems.
Yeah.
Where they
Yes.
You're basically reacting to noise.
Yes.
Real system signal.
So I don't want to comment specifically on this particular case, but the question was that there are very poor cases in industry where people make use of data in ways that are statistically completely undefendable, like basing yourself on a few data points. Yeah, in general, AB Volvo, in my experience, focuses on two things predominantly: uptime of trucks and fuel efficiency. Is that a fair way of putting it? And there, my feeling is that they have a lot more data available that they are collecting, because in our experience, and I have to be a little bit careful because we're being recorded, but AB Volvo is among the companies that has the largest amount of data in the software center that they have. But that doesn't mean that it's always used in the right way. Yeah? There is a statement that says you can do spaghetti programming in any programming language. You know that one? The same is true for data. Yeah, you can just make really bad decisions, but it's a fair point. Thank you for sharing. Yeah? Are you with me so far? You know, the interesting thing is people with my last name, Bosch, when they moved to the US, they changed their name. Do you know what they changed it into? They changed it into Bush. So for a long time, I was afraid that I was related to the guy. But then Trump came along, and I thought, who cares, right? Here's the big thing that I wanted to talk about, and I wanted to, one of the people here in the front row already commented on this. You get a requirement specification. You build what it says in the requirement specification. You test it. You deliver it to customers. Did you deliver value to customers? That's, I think, the assumption that most engineers have, is that yes, I delivered value because the customer asked for it. I gave what they asked for. Of course, they should be happy, right? Well, here's a very old study from before most of you were born, I suppose, 2002. Yeah, oh, that was not funny, or maybe it was funny, I don't know. Somewhere between half and 2/3 in the features and functions in a typical system are either never used or they're used so seldomly that they shouldn't have been built in the first place. So what I tell most companies that I do consulting for, half of your development effort is waste. You just don't know which half. I can help. It's a pretty good sales pitch, you gotta give me that. Right? The responsive should try that. We couldn't believe these numbers, so we did our own study a few years ago with a company in the Gothenburg region that wanted to stay anonymous after they saw the data. And we see exactly the same pattern. On the x-axis, you see a whole bunch of functions and features in that system, and these are features that are intended to be used. And we see exactly the same pattern. Some features are used all the time, some features are used occasionally, and many, many features are never or hardly ever used. Yeah? And remember, these are features that were intended to be used. My car has an airbag feature. I hope the airbag feature is never used. These are features where some product managers stood hopping up and down in front of a prioritization meeting saying that unless we get this feature, we're all going to go to hell in a handbasket. And then you get it prioritized. You get it built. You start to collect usage data, which many companies don't do because they don't want to know. Yeah, and then what you get is crickets. Yeah? That's the first data point. Half of everything you build is waste. The other one, I'm not a very smart person. You must have figured that out by now. So I can only do simple models. This is a very simple model. Every product, every portfolio, every category of, or group of products, every platform has 3 layers of functionality. A layer of commodity functionality, stuff that you need for your product to work, but no one gives a flying hoot about it. It should just work. Yeah? Your car has brakes, who cares? Your phone, you can make calls with your mobile phone, who cares? Yeah, it's not a differentiator, it's a commodity function. On top of that sits differentiating functionality. Yeah? I have level 4 driver assistance, which means I can let go of the steering wheel on the highway. Yeah, something like that. Or my phone has 5 different cameras on the back side of the phone, and I can make the most amazing pictures, etc., etc. On top of that sits a layer of innovative and experimental functionality. And you all know, all of you, I think, are at product companies, except for a few consultants who work for their own company for product companies. Yeah, but what you do is you first try to figure out what are new innovative features that you would like to bring into your product. 1 out of 10, 2 out of 10 are successful. Those you pull into your differentiating functionality layer, they sit there for a while and then they become commodity. Yeah, after a few weeks, a few months, a few years, they become commodity. I have now asked well over 50 companies what percentage of R&D resources go to commodity functionality and what percentage of R&D goes to differentiating, innovative, and experimental functionality. And the answer is that somewhere between 70 and 90% of all R&D resources in a typical company go to commodity functionality. Functionality that you already have, that just needs to be maintained, and that does not add any value or any differentiation to customers. They will not pick you or buy you because of that functionality, but still 7 to 9 out of every 10 people work on that stuff. I think that there is some slight room for improvement. What do you think? Yeah, so let's break this down, and then we go to the AI part of the talk. 7 to 9 out of every 10 people work on something that no customer cares about. It should just work. The 1 or 2 that build new stuff get it wrong half the time. Now I want to put some numbers on this. Yeah? I have a company. Sorry, I know you're all engineers, so you can do math, right? Okay, the response was not very confident. If I have a company that spends 5% of its revenue on R&D, then most product companies use their revenue and then a percentage of revenue as their R&D budget. Welcome in. Yeah? How much revenue should every euro, Sweden is soon switching to the euro, right? Not ever. How much revenue should every euro invested in R&D create? Any guesses? I'll give you the answer because I need to speed up because I'm going too slow. The answer is 20x, because 5% fits 20 times in 100. Which means that every euro that is invested into R&D has to generate 20 euros of business value. If we now go to agile teams, I have an agile team of 8 people. I have a 3-week sprint. I don't care how you calculate this, but this is one way which makes it easy for me. That gives me 24 person weeks of effort, which is about half an FTE. Are you still with me on that one? Let's assume that a fully loaded person year, including overhead and taxes and office and a car and computer and salary and all this other good stuff, is about 200,000 euros a year. Yeah, which is a bit over 2 million a year. Which I don't know where you guys are, but that's not entirely unreasonable in most parts of the world. That means that the cost of the R&D team for one sprint is 100,000 euros. You still with me? But the value this team has to generate is 20 times 100,000 euros, which is 2 million euros, which is something like 22 million SEK. And now I want to see a raise of hands. Who works at a company where every agile team, every agile sprint generates over 20 million SEK in value for the company? Come on. Really? But you see the math, right? You see, well, you may think that we're really good at software engineering, but I see that the effectiveness in terms of how much value do you create per hour invested in your time is actually really poor. We may be very efficient. We may be cranking out lots of features in our sprints, and we may be working down our backlog very, very quick. But if these are features that no one cares about and no one uses, then why bother? Yeah, so I just wanted to do this as a bit of a reality check. Most people do not, and now I'm worried because Vasco is going to ask a question. Most people don't think about the reality of this. Sir, go ahead.
So I'm with you. So I'm with you so far. I think you're making a very persuasive case. But aren't we the ones to blame? And I mean, you and I, the people who came before and started talking about how to do software engineering the right way, quote unquote, when we focus so much time and so much effort on writing the right requirements, on writing the right use cases, instead of validating that those initial assumptions were even remotely valuable.
Yeah. So and now the question becomes, whose job is that? And traditionally you would say, it's product management that tells me what to build, and then I as an engineer figure out how to build it, right? That has been the traditional breakdown. But when I worked in Silicon Valley, what I noticed is every engineer knew down in their guts what business we were serving. And they understood, because of empathy with the customers that we were serving, what was important to those customers and how those customers wanted to have things realized. And maybe that's the wrong way of putting it, but at least that's what I believe is the responsibility of engineers. It's deciding what to build, and the details of what to build is too important to leave to the product managers. Yeah, you have to take a responsibility here. I believe that that's important. I will go and speed up now, because I thought, oh, I have an hour, but then he took all this time. Sorry, Thomas. Bad joke. I said, okay, you can handle it, right? Yeah, good. I want to talk a little bit about AI maturity models. Yeah, I will go a little bit quicker to this, but what we did was we did an interview study with the software center companies and also some other companies on how are they actually working with AI. Yeah, and I think that that's a quite interesting one. And what we did was we found the people in those companies that were responsible for introducing AI into those companies. And we had we had well over 15 companies, well over 25 interviewees, and we did this in the first half of this year. Yeah, and what we did was we have 3, and I cannot remember if I put the 4th maturity model in there, 3 or 4 maturity models. This is how does the company as a whole work with AI? So what are the different business processes and how do they work with AI? And what we start with is playtime. The first step is when people use LLMs and agents for simplifying existing tasks. I mean, this may be email generation, generating some documentation. You ask ChatGPT or Perplexity or one of the other ones, please formulate a response to this email, and then you edit a little bit and poof, off it goes, right? The second one is automation 2.0. If you look at a business process, you very often have steps in the business process that have been automated because you could automate them, and then there are some steps in the business process that you couldn't automate yet. So what you do is you basically now use LLMs to automate steps in an existing business process that you could not automate earlier. You with me still? Yeah, makes sense, right? Third step, this is what, for instance, Philip Morris did. The head of AI there sat down with every business process owner in the company and did a complete zero-based design for that business process. So they threw out the existing business process. They looked at what is the input and the output of this business process, and how can we redesign this business process from an AI-first perspective. You with me still? Yeah, and then what you do is you do everything that AI can do. I let AI do, and only the things that AI cannot do, we give to humans. A little bit like the Uber driver. Yeah, we don't have autonomous vehicles yet, which annoys people like Uber to no end. So they still have to pay those pesky car drivers. Yeah, but they are working for the algorithms. The humans are working for the algorithm. They're not working on the algorithm. You're with me, yeah? Makes sense. The next step is super agents. In super agents, you start to connect previously disconnected business processes. So for instance, R&D and procurement can now be connected. That often it used to be that R&D designed the product and then told procurement, go and buy these parts. But now you can actually have a process where procurement comes back and says, let's make changes to the product in these places. Then we can buy these larger subsystems at a lower price, which will lower the overall cost of the product or improve the performance of the product or something like that. And then finally, what we call Nirvana, the AI-driven organization, where everything is done from an AI engineering perspective. The second one is probably a little bit more interesting to you. It's about what does the AI-driven R&D process look like? And here is what I believe is happening. The first step is the AI assistant. That's where individual engineers use LLMs and Gen AI in general to automate some of their tasks. Test case generation. Who uses AI for test case generation? Come on, people. Really? I get like 4 hands in the entire room. You have to do better than that, really. Code generation, cursor, and other kinds of tools. Now the hands are starting to come up a little bit more. If you use LLMs for both code generation and test case generation, don't use the same LLM for both, obviously, right? Just for the record. The next step, which we're now starting to see in several companies, is the AI compensator. I have a team. The team has to do some development in an area where it's not very competent. Either it doesn't know the domain, it doesn't know the regulatory compliance standard that it has to follow, it doesn't know some technology that it has to work with. And then you give the team an agent that compensates for some of the lack of skills within the team. Yeah, and then that agent basically compensates for some of for the things. The third step is the AI supercharger. The AI supercharger is where I replace everyone except maybe 1 or 2 people in the team with AI agents. Yeah, and then you as an individual get supercharged because you have a bunch of agents around you. Yeah, we have one case at one of the software center companies, one of the German ones. We have 2, I won't tell you which one. Yeah, where there basically is an enterprise architect who was going to get 2 agile teams in order to support him, it's a guy, to support him in his work. But instead, he got 5 agents. He got a documentation agent, a design agent, a coding agent, a quality assurance agent, and a documentation agent. And the only thing this guy does is supervise the output of these agents and provide prompts to these agents. And he, by himself, is generating code that should have been generated by 2 agile teams. Yeah, and just to give you a bit of a feel, my middle one works for Lyft. You know Lyft, the Uber competitor in the US. He's based in San Francisco. He has now really picked up. He's a machine learning engineer, but does a lot of software engineering. Yeah, he has really picked up on this. So he is now able to, by himself, these are his words, not mine, to do the work of 2 agile teams. And not only that, because of using these tools, he is able to contribute code to code bases owned by other teams, written in languages that he has never programmed in. You with me? He claims that more than 50% of the pull requests that he does, he never even touches the code. It's just generated. So if you're not using these tools, people, then you're doing yourself a disservice and the company that you work for a disservice. You have to jump on this bandwagon. That's where the world is going. Yeah, you are supposed to be the vanguard of technology adoption, not the laggards. You're the engineers. It's your job to do this. Your job is not to just convert the requirements into code. Any monkey can do that. Your job is to lead in adopting new technologies that makes the generation of code more efficient and through that companies more effective. The next step after this is the lovable stage. You have all used Lovable? Who has used Lovable? Okay, again, you don't get out much, right? Sorry, yes, go ahead.
I have a friend who gets the Lovable apps when they need to be ready for production. I have a friend who gets the business requests for the Lovable apps when they need to be ready for production.
Yeah.
Like, it doesn't have, it's all most done. It's never seen a user, and you can't log in, and it doesn't follow GDPR. How many hours do I need to pay you to fix that?
He wants the microphone back. I'm not saying these technologies are perfect, but they are a heck of a lot faster. Let me give you my story then. I'm in the process of starting a company around the AI Act, together with someone in the Netherlands. I use ChatGPT. We need a website. I use ChatGPT to generate the brief for the website. You with me? Then I go to Lovable. I take this 2-3-page website brief and give it to Lovable. And out comes a website that literally takes me a few minutes to complement the information on, and I'm done. So yes, there are bad examples, but there are also very good examples. And I think websites maybe is a little bit easier than mobile apps. Sir, go ahead.
Have the processes that are quite atrocious, really.
Yes.
And when you automate them, you make bad things go faster.
Yes. Yes.
So you can get worse results.
Yes. And this is why, if you, on the previous slide, when you reach a certain level of maturity adoption in AI, you go and redesign processes. You don't go and
but we
look at
also
the
have
existing
research
processes.
now that says that maturity models can make things worse.
I want to see that research because I write a lot of maturity models, but that's fine.
There has been comparisons between maturity models and capability models, and I think it was Dora, I'm not quite certain. And the conclusion was that capability models tend to work better than maturity models.
Then I will start to rename my maturity models into capability models.
Okay. Well, that's the usual solution.
That's my fast solution. Thank you for that. The idea is step number 4, you give the intent to the system. The system generates this system. Yeah, so we're moving from building the machine to software engineers building the machine that builds the machine. You see where we're going? People, if you come to conferences like this, it's clear that you're interested in what is happening in the fields, right? Software engineering is fundamentally changing. You have to be on that bandwagon if you want to stay in the game. And many of you are way too young to start to think about retirement. Yeah, so you have to go with this flow. This is where the world is going. It starts in the SaaS companies, then it slowly comes to the embedded systems companies, then it goes to the banks and insurance companies, but it is coming your way. You can see it coming. The reason that we talk to companies like Microsoft and Bing and Klarna and King and others is because that's where these things start to happen first. Because they have the easiest problems. They have the least regulatory compliance issues and other kinds of integrations with mechanical and electronics parts. But it is coming for us too. You can just pretend, put your hand in the sand and pretend that it won't happen, but that won't get you anywhere. Yeah, so we have to be on top of that. The last one is the Kaizen AI generator. That's the AI agents stay with the system because they then continuously improve the system. They regenerate code at runtime to figure out if there are better ways of doing things. Yeah, this is what is happening in R&D. Yeah, so software engineering, this is not me, this is Andrej Karpathy, one of the co-founders of OpenAI. We used to have, a long time ago, the phase that you all hated. We had managers in the middle, we had a bunch of engineers around it, and the manager would tell the engineers what to do. Then we moved to Agile. Yeah? We moved to managers and everyone had to coordinate with each other. And then we get to extreme collaboration, the workshop you had yesterday, if I remember correctly, and those kind of things. The next is AI assistant software engineering. Yeah, that's what we just talked about with the AI supercharger. You have one person in the middle. Sorry, it's supposed to be a guy, but I see actually many, many very competent women in that context as well. But basically you have a set of agents around you, and those agents are doing a lot of the work for you, and you become the thing that you never wanted to become, a manager. You become a manager of agents. Yeah? And the final stage is you provide the prompt, and the autonomous software engineering agent basically works with all the other agents and generates what you're looking for. This world is becoming reality. Sir?
I'm afraid of the 4th stage because I see...
Wait for the mic, please.
Yeah.
I'm afraid of the 4th stage because I see manager-driven AI systems being built like spec kit by GitHub that basically put the first step in the 4th step, creating humongous amounts of documentation before any code gets written, yes, and having 4 or 5 layers of agents before software gets written. So I hope that we can skip the 4th and kind of take the 2nd and make it the 5th. So maybe that's a tip for your next version of this. Yeah, but software engineering 5.0.
This is not my slides, but I appreciate the suggestion. Yeah? AI-driven products, again, I have to speed up because I want to leave some time for questions. You all look a little shell-shocked, and is this good news or bad news, what I'm sharing?
I think it's both.
You think it's both, okay. Static machine learning models, dynamic machine learning models that are basically learning on the fly, multi-machine learning models in the product, continuous machine learning when the system collects the data, has the feedback loops, and the models improve themselves on a continuous basis. And then finally, AI-first products, which are basically organized around the AI models rather than the AI models being bolted on the side. I'm in the midst, we published a paper on this that I happily send to you if you ask me for it. Also, if you go to my blog, I'm just in the midst of writing an entire blog post series on this thing. Yeah, but just to give you a feel for what some of what those things can do, this is research that we've been doing in the past. This is at Ericsson, optimization of parameter settings in base stations, where we basically had an experimentation backend that was changing the requirements or the parameters on a Ericsson base station in order to optimize minimize the power output and optimize the connection time and the number of phones that were able to be connected. This is steering wheel angle prediction with an automotive company using a end-to-end federated learning system where you have a whole bunch of vehicles that are basically learning together the best model for a steering wheel angle prediction, which is important in the ADAS space. This is actually a quite interesting case. Ericsson has emergency base stations. So if there is a crisis, something bad happens in some part of the world, there is some disaster, and the ground-based base station is basically disabled, you can make UAV base stations. So these are drones that fly and act as base stations. But if you are in a disaster area and you have rescue workers working in that area, you need to optimize where do I place the drone so that it has optimal backhaul channel and it has optimal connectivity to each of the rescue workers. Can you see that case? And that really depends on where are the rescue workers, where are the base stations, what is the weather conditions, and a few other things. So we have worked on reinforcement learning that optimizes the position of the base station at runtime. So even when people move, the drone may move in order to make things happen. And then we did this one step further, where we did it with multiple drones that together are optimizing their position in a disaster area in order to give the optimal connectivity. Yeah, these are the kinds of things that if you would have to program this algorithmically, it would be incredibly difficult, but it is actually very easy to do this. And then we have one on ecosystems that you will never learn about. The one thing that I want to stress, though, is Sam Altman, founder of OpenAI, or co-founder of OpenAI, basically has a standing bet with his friends when the first company, single-person company, is formed that will become a unicorn. So that's one person, hundreds of thousands of agents, and a valuation of more than $1 billion. And you know what they say, $1 billion here, $1 billion there, and soon we're talking real money. I want to spend a few minutes on the software development lifecycle 2.0. What is changing? Well, the interesting thing is the distinction between design time and runtime is disappearing. It's becoming the same thing in many systems. AI models are running next to traditional models and components and are replacing them. Fast automated feedback loops are incredibly important. We used to do all the planning and then deployment. Now it is get deployed as quickly as possible, get the feedback loop going, and learn. The sequence and dependency between requirements, architecture, and code and test cases being inverted. It's all about the running system. Everything else is derived from that. The relation between product and a fleet of products is exploited much more strongly. And then the nature of certification is moving from static and pre-deployment to continuous and post-deployment. So that's what I believe are the changes. So if we then look at what is a system, and I'll wrap up, Thomas, soon, because I just want to get this across. Any running software system has three important parts. It has software, it has AI models, and it has data that it generates. Yeah, that's the starting point. Then we go one level up. I hope this is readable. It looks great on my screen, not so great on this screen. Yeah, but if you look at the code, you have two types of code. You have manually written code, that's what you spend most of your time on, and then you have generated code. Yeah? If we look at data, we have data that is used for external use, data that's used for system use, that the system uses itself, and data that is generated for training AI models. If we look at AI models, we have three types. We have offline generated models, yeah, that you basically insert. You go to Hugging Face, download a model, put it in your product. We have code generating models that are generating the generated code. And then we have federated reinforcement learning, or reinforcement learning by itself, or federated reinforcement learning, which has models that learn at runtime while the system is running. You still with me so far? This is where we're moving. The next step then becomes, well, I have an intent. What is this system intended to do? And that tends to translate itself into a set of measurable KPIs and a set of requirements. And you know what's happening? Those tend to now be generated. Just give me what you want. Tell me what you want, and I'll generate requirements and measurable KPIs and other kinds of things. Architecture, yeah, we all love architecture. I actually am considered to, I did a lot of work on software architectures in the 90s and early 2000s. Yeah, and I used to say, oh, you have to carefully design your architecture because if you make wrong decisions, you will have really hard time with the non-functional requirements of the system and stuff like that. And now what we basically see is that the architecture is generated out of the running code. The architecture that of the system is basically derived from what is actually running in reality. Then we look at quality assurance. Well, what we see is that quality assurance is that I have the requirements and I have the KPIs. So what I do is basically I generate my test cases from the requirements and from the KPIs that I have. I don't have to write them anymore. I basically test them. You can keep taking pictures because this keeps building. I will tell you when it's over. Yeah. Then we have regulatory compliance. How do we know that we're actually compliant? Well, you know, I generate my regulatory compliance, by collecting all the data from external use, the data from the test cases, and that comes from quality assurance. And based on that, I can have runtime, real-time, fully automated evidence that I am compliant to the regulations that I am supposed to be subject to. Safety, in fintech, you have all kinds of things around that you have to know your customer, you have to follow GDPR, you have to know what is operating in runtime, etc., etc. I'm out of time. So, and then of course, all of this happens all the time. We have a continuous loop for an entire fleet of products because, you know, you need all kinds of cars and they need to learn from each other. And then we get to conclusion. You happy to see conclusion? Enough bad news for one morning? Huh? So one, come on. We suck at building code. Gen AI can help, but it requires you to work differently. Not more complicated than that. Oh, I'm not done yet. I write books. Don't write books. It's an awful use of your time, especially if you give them away for free. I give them away for free, so if you go to my website, then you can download them. I am involved in some startups, costly for fintech and regulatory compliance in fintech. Another one around the AI Act, if you're interested in that. And then finally, Jan, where do we find your website? Well, it's janbosch.com. I tried to get bosch.com. Didn't work, yeah? But with that, thank you very, very much for your attention, and I'm happy to answer any questions you might have.